Indian cities lack adequate sewage treatment facilities. Central Pollution Control Board of India estimates that India generates about 62,000 million liters of sewage daily, of which only 23,277 million liters are taken care of, thereby leaving almost 62% of wastewater unprocessed. The absence of proper sewerage facilities results in wastewater going into open fields, ponds, or directly into rivers. This problem of wastewater falling into rivers has critically polluted many Indian rivers, including Ganga, which has a considerable economic and cultural importance in the country. About 144 major dirty water drains outfall into the Ganges that traverses a course of about 2,510 kilometers in India and accounts for about 26% of its landmass and 30% of its water resources. In recent years, this growing problem of water pollution has attracted government's attention. Some genuine efforts have been undertaken to tackle this increasing pollution of rivers. Importantly, these attempts extend beyond big cities and endeavors to include smaller towns and villages as well. For the first time, along the river Ganga, the National Mission for Clean Ganga has identified villages that contribute to polluting the river. The difficulty, however, is that the existing high-rate sewage treatment systems like activated sludge process, sequencing batch reactors, moving bed bioreactor are not appropriate methods for small towns and villages. The dearth of energy and skilled workforce in rural India acts as roadblocks in the smooth functioning of these advanced wastewater processing systems. Considering these fundamental problems, the Government of India and European Commission, under the Bilateral Cooperation Agreement in the field of science and technology through 7th Framework Programme, took the initiative to support 4 research and development projects in India to address the thematic priorities in water sector. Out of these 4, the Safeguarding Water Resources in India with Green and Sustainable Technologies, or SWINGS project, endeavored to find solutions of these problems and develop optimized, low-cost and sustainable wastewater treatment systems, combining anaerobic process, constructed wetlands, and solar-driven disinfection methods.
Greeting from Aligarh Muslim University, graded by international ranking organizations and Indian ranking organizations, MHRD, as one of the leading universities of the country. We are leading because of the quality of our research, and one of the most important projects undertaken by AMU is Project SWINGS, which is recycling wastewater without energy costs.
The project has developed innovative and sustainable water treatment technologies for water reuse so that wastewater can be transformed and used for irrigation, horticulture, fish farming, public cleaning systems, and even for drinking. These easy-to-implement methods can be further applied to the wastewater management and reuse in townships, golf courses, and construction industry.
I am certain that this project will be used in great measure in cleaning up our sacred rivers Ganga and Yamuna. We are already involved at Narora, where we will implement this project. Hopefully, it will be accepted across the country.
At a time when several parts of India are battling with severe water scarcity and droughts, and almost 100 million Indians are living in severely water polluted areas, technological solutions deployed and validated under SWINGS can provide rural and small communities with efficient methods to effectively and cheaply deal with this water crisis. The idea is also to be prepared for an imminent grimmer water supply situation emerging by 2030. SWING's project consisted of 10 partners from Europe and 8 from India, Aman Technology Center of Spain being the Europe coordinator and Aligarh Muslim University being the India coordinator. Under the SWING's project, 5 pilot plants have been implemented at different places in India. These places are Aligarh Muslim University at Aligarh, Kalyani University at Nadia in West Bengal, and Indira Gandhi National Tribal University at Amarkantak, Madhya Pradesh. Out of these, the Aligarh Muslim University plant is the largest one, comprising 3 demonstration units.
The SWING's research project was started in January 2013 and completed in January 2016 with a total outlay of about 2.1 million euros. Amongst the Indian partners, AMU had a major share that we received from the Department of Science and Technology. SWINGS has established a very dedicated lab for water and wastewater testing in the Department of Civil Engineering. A good number of research scholars are doing their thesis and collecting monitoring data from the pilot plants at Aligarh Muslim University. We are keen to participate in such research and development projects supported by national and international funding agencies like European Commission.
AMU has implemented the largest pilot under the SWINGS research project. It has 3 demonstration units within the same site in the campus. The sewage water is collected, that is the sewage treatment plant based on the Tickling filter owned by the AMU, and then fraction of the wastewater for SWINGS pilots is taken from this plant and it is collected into the holding tank after primary treatment. And from holding tank, the wastewater is pumped to the anaerobic digester for biochemical reactions under anaerobic conditions that results in the reduction of organic pollution and solids pollution load quite significantly without any energy input. And it also produces methane-rich biogas which can be converted into electricity. And then the wastewater, after treatment in the anaerobic digester, that is USB technology, is conveyed into the siphon. And then siphon with some force supplies the water to the vertical beds. After the first stage of treatment, that is in the anaerobic digester, based on the USB technology, the treated effluent enters into the vertical flow constructed wetlands. So we have 2 identical vertical flow constructed wetlands. One is with recirculation and another is without recirculation. In one of these beds, where we have recirculation, we are trying to ensure nitrification and denitrification passes. The vegetation which has been used in these 2 identical beds is local and indigenous. We are using Phragmites, and in another bed we are using Karka. This is the natural aeration ducts which goes deep down to the vertical flow constructed wetlands to enhance the dissolved oxygen concentration in the bottom so as to create the aerobic conditions. All these vertical flow constructed wetlands operates under the unsaturated conditions, and then the wastewater after treatment, from here it comes into the 2 pipes and then it's taken to the chamber for further division into the respective horizontal flow constructed wetlands. The effluent from the vertical flow constructed wetland is collected into this chamber and it is mixed together, and we can see the quality after the vertical flow constructed wetlands. This is the quality. It's very clean and clear and it has no turbidity, and the pollutants are almost removed. From this chamber, the effluent goes into the 2 respective horizontal constructed wetlands. One is the east side and another is the west side. Each bed is vegetated with 3 different species which are indigenous. One is the Sagittaria, Iris and Canna indica. Out of total treated water, from vertical flow constructed wetlands and horizontal flow constructed wetlands. 10% of the treated volume is taken for disinfection. We have two different techniques for disinfection. One is the anodic oxidation and one is the UV. Both are solar driven systems. So this is the effluent quality after disinfection. One is on my right hand side is UV and left is AO. And this you can see the raw sewage. This is the dirty water and here we have the clean water.
Another type of constructed wetlands that has been installed at Aligarh Muslim University site is French type system comprising vertical and horizontal flow. Compared with vertical and horizontal flow constructed wetlands, this type of system is compact and may produce the same quality of effluent using small footprint.
Well, Swings project hopes to bridge the gap between the shortage of water and recycling wastewater without energy costs. Dr. Nadeem Khalil has spearheaded this project and I've been visiting the site occasionally and I've been very impressed at the quality of the work done. I wish this project a success and I'm very confident that it will lead to a great use of the technology in recycling of wastewater. Thank you very much.